Hello, my name is Raymundo Cassani. I'm an associate researcher at the INRS in Montreal, Quebec. I'm going to present this initial investigation into neurophysiological correlates of Argentine tango flow states. This work is a case study. In recent years, Argentine tango has been used as therapy to improve the physical fitness on older adults and to alleviate symptoms in people suffering of Parkinson's disease, depression, anxiety, among others. Indeed, multiple works have shown that dancing with a partner to music has more positive emotional effects than without a partner or music. Mental flow is a subjective experience in which people feel they act with total involvement. It has been reported across a wide range of activities such as sports, learning, dancing, playing music, and working. Flow is often linked to moments in the activities when demanding challenges meet a high level of skill. In the case of Argentine tango, flow is a strong predictor of perseverance in practice. Flow is typically evaluated with after experience questionnaires. However, with these methods, it's hard to put the flow experience in a scale. They may be administered far from the flow experience and they cannot be used during the experience. To overcome these disadvantages, psychophysiological methods have been proposed to explore the relationship between the cognitive state of subjects and the effects that it has on their physiological signals. As such, these methods can be used to explore correlates between physiological signals and flow. Methods based on multiple physiological signals provide a deeper understanding of the perception process and a better estimation of flow. Moreover, as it takes two to tango, this multimodal approach needs to be used simultaneously for the two dancers. This is known as hyperscanning. This work has as objectives the following. First, to validate the usability of the acquired signals EEG and ECG. Second, to explore the correlates between self-reported flow and EEG and ECG features. And last, to explore the synchrony of the physiological features between subjects for different conditions. To the best of our knowledge, this case study is the first attempt of multimodal hyperscanning of Argentine tango dancers. For this case study, two experienced Argentine tango dancers selected three songs that have different flow-evoking properties. With these songs, both dancers underwent different dancing and non-dancing conditions. Flow level was self-reported by each dancer after each song. In this work, we focused only on EEG and ECG signals. EEG was acquired with the Cyton board by OpenBCI using 8 channels. Also, 3-axis acceleration was recorded. ECG signal was acquired with the Bioharness 3 chest band. For EEG preprocessing, signals were visually inspected to detect major active artifacts. The signals will bandpass it from 0.5 to 30 Hz, and we use the wavelet enhanced independent component analysis WICA method to enhance the EEG signals. EEG features were computed across 8-second windows with 50% overlap, and classic spectral features were computed. This is to say delta, theta, alpha, low alpha, high alpha, and beta. ECG signals were also visually inspected to detect major artifacts. They were bandpassed from 4 to 40 Hz to enhance the QRS complex, which was detected with a modified Pan-Tompkins algorithm. The tachogram was corrected for missing R peaks, and the tachogram was resampled at 4 Hz. For ECG features, these were computed over 60-second windows with 70% overlap, and classic time and frequency heart rate variability features were computed. A total of 15 trials were acquired. However, 3 of them needed to be discarded, as trial number 2 had problems with the recording. Also, trial number 5 and trial number 14 were designed to avoid flow as they were dancing, but there was no contact between dancers. The Spearman's correlation values for the flow scores between dancers were 0.35 for sitting and minus 0.33 for dancing trials. Regarding the impact of motion in the EEG signals, most of the motion artifacts were removed with the WICA algorithm. Unlike other physical activities such as running, acceleration in the head did not present acceleration values higher than plus minus 0.1 g. We did not find significant differences between the correlation of acceleration and EEG signals for sitting and dancing conditions. EEG features were average across electrodes and across the song duration. Then the Spearman's correlation with flow was computed. For sitting trials, positive correlations were obtained with features in the alpha band, and the low frequency bands delta and theta consistently presented negative correlation values. For the dancing condition, in turn, only correlation for the spectral features in the theta and beta bands had the same sign in both dancers. EEG features were average across electrodes, giving one feature time series for each song. Then the Spearman's correlation was computed between dancers for the same feature. Dancing trials presented higher correlation values, specifically for the delta and beta bands. ECG features were average across the song duration. The Spearman's correlation between ECG features and flow level presented higher absolute values in the dancing trials. Spearman's correlation was computed between dancers for the same ECG feature. Dancing trials presented higher correlation values for features such as mean RR and SDRR. From this work, we can draw three main conclusions. First, this portable multimodal hyperscanning setup was possible due to the recent technological advances. Secondly, motion-related artifacts are reduced with the use of portable devices as they move with the subject's head. Lastly, the results on physiological correlates with flow levels and synchrony between dancers are promising. Sadly, due to COVID-19, further experiments with a larger sample are on hold. These are some references used in this presentation. We would like to thank Kermit for their funding of this initial investigation. Thanks for watching. If you have any comment or question, do not hesitate in contacting me. Have a nice day.